Okay, so what I want to do now is look at another special situation of having each period constant principal repaid. Okay, and I think it's most effective to look at this through an example. Let's do the books example. So you have a loan of 3,000 at an effective per period interest rate of 2%. And you pay that off by 12 payments, beginning one period after the loan is made. Each payment consists of a principal repayment of 250 plus whatever interest is due in that period. Construct an amortization schedule. Schedule means table. Okay, so yeah, so let's see what's going on here. Okay. Well, so you take out this $3,000 loan. You're paying $250 in principal. So that means, at the end of the first period, you pay $250 in principal. So by definition, that means you now, at the end of the first period after that payment, you owe $2750. It's just 3,000 minus 250. Okay. Well, we're interested in what the actual payment was. Okay. So to do that, we got to figure out what interest was. Well, so remember that this 3,000 accrues one period of interest, and interest is 2%. So 3,000 times 0.02 is 60. Okay. So the interest due in the first period is 60. So you have to first pay off interest and then you pay principal. So the total payment is the 60 interest plus the 250 principal, which is 310. Okay. Now let's figure out everything for one more period. Okay. So again, same thing, 250 principal paid at the end of the second period. Okay, that means you're chipping away at the $2750 by $250. So $2750 minus $250 is $2,500. Great, but we really want what this actual payment was. Well, that's easy to figure out. $2750 accrues one period of interest at 2%. $2750 times 0.02 is, you can check, 55. So that means, well, you pay off the interest and the principal. So 55 plus 250 is 305. And et cetera, et cetera, et cetera. So you can see, interestingly, that under constant principal being repaid, of 250, and I should mention, where does 250 come from? Well, you have 12 payments in order to pay off your $3,000 loan, and if you want to divide the principal repaid into 12 equal payments, well, 3,000 over 12 is 250. So you got to pay 250 each period. 12 times 250 is 3,000. Okay, so if you do this, you'll notice that this is a decreasing type of annuity like we've dealt with before. So in general, and oddly enough, the book doesn't have this formula anywhere, or these formulas, which I don't really understand, but so if we have a loan L, it's repaid by n payments at the end of each period in such a way that constant principal is repaid each period, then, well, first of all, that constant principal is going to be L over n, because you're making n payments of this amount. N times L over n is L. So you have the loan fully repaid at the end of the nth period. Okay. Well, each period you're chipping away L over n at your original loan amount, your original outstanding balance of L. So after t periods, that's LT over n that you've paid towards principal. So your outstanding balance is L minus LT over N. Nothing subtle there. Okay. Well, between period T and T plus 1, this accrues interest and interest rate J. It accrues one period of interest at interest rate J, so that the interest due in the T plus 1 period from T to T plus 1 is just J times your outstanding balance at the end of the Tth period. Okay. And that leads us to the most important formula, which is what the payments are. Okay. And in particular, we just add principal. We add PRT plus 1, but that's still L over N. It's principal is constant throughout the loan, so we add constant principal plus this interest to get L over N plus J L minus LT over N. And again, this oddly enough, the book doesn't have this formula, even though you really need it for the homework. But anyway.
Okay, what I want to do now is an example using this formula that is similar to a former exam FM problem and similar to two collected homeworks. So you're loaned $3,600 from a company and you wish to pay it off over 12 months. Constant payments of principal where I-12 is 12%. So the total payments are not constant. It's the principal payments are constant. Yeah, so meaning as a sanity check, you're making 3,600 over 12 payments of principal each month for a total of, well, 300 times 12 is 3,600. Again, just a sanity check. So right after the 6th month, company X sells a loan to company Y, and company Y is demanding a yield of I-12 is 15%. And all that means is this is the rate we're pricing the rights to these loan payments right after the 6th month. Yeah, what's the price company X gets, right? So probably good to draw a time diagram. Can't hurt. There's a bit of a sanity check, though you really don't necessarily need it. Okay, so we're starting right after 6 t equals 6 months. Don't really need all of these, but I guess there's harm. Right, so it's as simple as, so it's right after the 6th month. So company X got the loan payment at t equals 6. So the new company Y is purchasing the rights to the last 6 payments, 7 through 12. Again, you don't have to draw this time diagram. I'm just doing it for as a sanity check. So the price equals PV. Okay, 7 through K12. And I-12 is 0.1. So let's figure out what this is. Great. All right, so going back to our formula, it's KT plus 1 is L over N. So let's see. Do this. Bear with me 1 second. It should be perfect. Okay. So 3,600 over 12. So remember, to be clear, we're finding the loan payments for the original loan, because that's what K That's what all these K's are. It's the loan payments for the original loan. So in the original loan, we have 12. Not a equals, that's a plus. Plus, so maybe I should get, sorry, I should get J first. Blue. All right, so this is just simply 0.12 over 12, because that's what I-12 is, 0.12, so 0.0. So my monthly interest rate is 0.01. 3,600 minus 3,600 T over 12. And I will let you simplify this to get 336 minus 3T. Right, so this is what I'm going to do. Write first couple, and then maybe write the last one, and we'll see the pattern. K7, or there's going to be a little trick here. Do this. We're going to write it as a constant annuity minus an increasing annuity. You can do it as plus a constant annuity plus a decreasing annuity, but that's a lot trickier in certain situations. I think it's much better to stick with, when you get this kind of problem, writing things out as a constant annuity minus an increasing annuity. So here, to be clear, T equals 6 because it's K, 6 plus 1 is 7. So T equals 6 here. This is 318. It's big. K8, 336 minus 3 times 7, which is 315. Okay, yeah, so K, you really don't need K9 if you want it, write it. But let's do the last one. K12 is 336 minus 3 times 11, and that is 30. All right, so this is going to be, so what I'm going to do is, so this clearly keeps decreasing by 3. If you really did want K9, you would get purple. That's the other ones. Well, you would get it as 312, etc. Yeah, 318, 315, 312. So we're decreasing by 3. So all I'm going to do is write this as something minus 3. Well, that's obviously got to be 321 minus 3. So that I can write this as 321 minus 2 times 3. This is going to be, you can check 321 minus 6 payments. 6 times 3. Guess it can't hurt to check. 321 minus 18. 3. And for example, the next one, K9 here, would be 315. Sorry. 321 minus 9. So this, yeah, 3, 2 times 3, 3 times 3, all the way to 6 times 3. So it's 321 minus a decreasing annuity starting at 3. So that's really what the payments are. Excuse me. All right, so yeah, present value is 321. This is an annuity immediate based on this time diagram. So 321 A6. What is J? Well, we're pricing this at 15% nominal monthly because that is what the problem says to do. So that's what we do. That's what it means to have a 15% nominal monthly yield rate. And plot this into the calculator, 0.15 over 12.012. Pricing this with a monthly rate of 1.25%. Okay, minus 3 IA 6 2 5. Yeah, I guess get this first. So let's get out of begin mode. 321 payment 6N 1.25 payment 321 payment 6N 1.25 interest, compute present value. So let's write this down, 1844.47. So I'll save it. All right, so remember the formula, 3 do this quickly in calculator, a double dot 6.0125 minus 6V to 6 over your interest rate. It's easy to do. Make sure you are in annuity due mode. Clear TVM. I saved that, so we're good. We'll go to annuity due mode. All right. 1 payment 6 and 1.25 interest, compute value minus 6 times 1.0125 the minus 6 over 0.0125 times 3. So I forgot to make that positive. So, right. So sorry, let me do that again. Minus 6 times 1.0125 6 minus times 3. So we call 1 1784 cents.
So let's talk about another interesting situation, which is payments as a percentage of interest. So let's say we take out a $300,000 loan That's paid off over 20 years, 20 payments at the end of each year. Effective annual interest is 7%. For the first 10 years, payments are 125% of interest due. Okay, and we don't know what exactly occurs for the next 10 years. Well, let's find the outstanding balance at the end of the first, so it should be the first year. Let's find the outstanding balance at the end of the, sorry, the 20-year loan. This is correct, sorry, 20-year loan. Let's figure out, using common sense, what the outstanding balance at the end of the first 2 years is under this scheme. Okay. Okay, so give me one moment. Okay, so this is a $300,000 loan. Interest is 7% annual effective. So the interest that you owe at the end of the first period is $300,000. That's your outstanding balance. Your starting outstanding balance times interest rate, 0.07, is $21,000. Okay, so you're paying at the end of the first period 125% of the interest due. So multiply this by 1.25, and you can check, you're going to get $26,250. Okay, so how much principal does that equate to? Well, let's find out. So principal, remember, is payment minus the interest due. Pay off your interest first, what's left goes towards the principal. 26,250 minus 21,000 is 5,250. Okay, so that means the outstanding balance at the end of the first year is 300,000 minus what you're chipping away at for principal. That's 294,750. Okay, so let's do this one more time. Okay, so I'll make this a little smaller. Okay, so this outstanding balance accrues 1 year of interest at 7%. So the interest due between year 1 and 2 is $20,632.50. Okay. Again, you're paying each year 125% of interest due in that year. So times this by 1.25, you're going to get $25,790.63. Okay. And so the principal that you pay at the end of the second year is just, well, take this amount here minus the interest that you paid. So $25,790.63 minus $20,632.50, you get $5158.13. So subtract that from the previous outstanding balance, and we get $289,591.88. Okay, so that answers the question here. So let's go back. Okay, well, this is really awkward to do, particularly if you're asked to find the outstanding balance, let's say at the end of the 9th year, something like that. And oddly enough, again, in the book, there's no formula for the outstanding balance. But you can come up with a formula. It's not very hard, and I would encourage you, if you're serious about this course, try and come up with this formula yourself. It's not too difficult, Requires a little bit of thinking, but that's all right. So in general, if payments are P times 100% of interest, so for example, P would be 1.25 in this example. 1.25 times 100% is 125%. So if this is true, then the outstanding balance after T periods is L times this quantity here. Okay, so you'll notice something if you're, thinking about this, and you'll notice that you in general really can't pay off your loan by doing this. Okay, I mean theoretically you can. What do I mean by that? Well, you can't realistically pay off the loan with this scheme. Theoretically, you can if you set P to be 1 plus J to the minus 1. If you do that, then this is just 0. So what's going on? Well, your original loan is L, and then after one period, you pay such a high percentage of interest that you pay off the whole loan. Now, for, let's say, why do I say this is unrealistic? Well, for J is 0.07, the example I had a second ago, that means P would be 15.29 roughly. So that means you're paying, at the end of the first period, 1,529% of interest. That's just silly. Okay, so realistically, you can never get this to be 0. Okay? The only way this is going to be 0 is if we're in this unrealistic scenario where everything inside the brackets is 0, which is just an incredibly high percentage of interest. So high that you pay off the loan after one period. Okay? So just something to be aware of in the homework, for example, that you're never in the homework paying off the loan with this scheme fully. You're always, for a certain number of years, like in this example, for 10 years, we're doing this scheme, and then for the next 10 years, who knows? So just something to be aware of. So let's do an example. This is a pretty straightforward example. Very similar to homework. A $300,000 30-year loan is taken out at effective annual interest 4%. For the first 10 years, payments are 110% of interest due, and for the next 10 years, payments are equal to interest. For the last 10 years, payments are constant. Figure out that constant. Okay, so let's see what is going on. Okay. And actually, before I do that, let's go and plug into our formula and check that we get the same answer for the previous example. Okay. So, yeah, sorry about that. So in this example, I mentioned, because this is 125% of interest, P is going to be 1.25, J is 7%. So 1 plus J minus PJ to the T, 300,000. That's going to be 300,000.9825 to the T. So plug in T equals 1. We get exactly what we had before, 294,750, which is OB1, 294,750. And plug in T equals 2, you get 289,591.88 cents. 289,591.88 cents. Okay. So now let's get back to the example. Right, let's get back to the example I wanted to do. So we have a 300,000 30-year loan, again 4%. First 10 years, payments 110% of interest due. Next 10 years, payments are equal to interest due. Last 10 years, payments are constant. Find that constant. Okay, so for this example, Right, so it's plug and chug for the first 10 years. Interest is 4%. Payments are 110% of interest, so P is 1.1. So we get OB10 is 300,000, 0.996 to the 10th, 288, 213, 71 cents. Well, for the next 10 years, all you're doing is paying off interest. So you're not chipping away at the outstanding balance, nor is interest being capitalized because you are paying all the interest. It's just you're not chipping away at your principal. So you have the same outstanding balance after 20 years as you have after 10 years. Again, you're just paying interest, and that's it. You're not touching your outstanding balance. So now we're going to implicitly reset the loan and basically think that we have a 10-year loan out, 288, 213, 71 cents, and we're paying that with equal payments of X. So we have this situation here. The present value of all these payments at 4% interest is XA10.04. That's got to be 288, 213, 71. So you solve for X, and you get X is 35,534.14 cents. So yeah, not a terribly difficult question.